Alright, I'm in the Pilot's Handbook of Aeronautical Knowledge, Chapter 4-8. This will be wingtip vortices, formation of vortices. The action of the airfoil that gives an aircraft lift also causes induced drag. When an airfoil is flown at a positive angle of attack, a pressure differential exists between the upper and lower surfaces of the airfoil. The pressure above the wing is less than atmospheric pressure, and the pressure below the wing is equal to or greater than atmospheric pressure. Since air always moves from high pressure towards low pressure, and the path of least resistance is toward the airfoil's tips, there is a span-wise movement of air from the bottom of the airfoil outward from the fuselage around the tips. This flow of air results in spillage over the tips, thereby setting up a whirlpool of air called a vortex. Let's take a look. Vortex. At the same time, the air on the upper surface has a tendency to flow in toward the fuselage and off the trailing edge. This air current forms a similar vortex at the inboard portion of the trailing edge of the airfoil, but because the fuselage limits the inward flow, the vortex is insignificant. Consequently, the deviation in flow direction is greatest at the outer tips where the unrestricted lateral flow is the strongest. As the air curls upward around the tip, it combines with the wash to form a fast-spinning trailing vortex. These vortices increase drag because of energy spent in producing the turbulence. Whenever an airfoil is producing lift, induced drag occurs and wingtip vortices are created. Just as lift increases with an increase in angle of attack, induced drag also increases. This occurs because of the angle of attack is increased. There is greater pressure difference between the top and bottom of the airfoil and a greater lateral flow of air. Consequently, this causes more violent vortices to be set up, resulting in more turbulence and more induced drag. In Figure 4.10, it is easy to see the formation of wingtip vortices. The intensity or strength of the vortices is directly proportional to the weight of the aircraft and inversely proportional to the wingspan and speed of the aircraft. The heavier and slower the aircraft, the greater the angle of attack and the stronger the wingtip vortices. Thus, an aircraft will create wingtip vortices with maximum strength occurring during the takeoff, climb, and landing phase of flight. These vortices lead to a particularly dangerous hazard to flight wake turbulence. Alright, avoiding wake turbulence. Wingtip vortices are greatest when the generating aircraft is heavy, clean, and slow. This condition is most commonly encountered during approaches or departures because an aircraft's angle of attack is at the highest, produce the lift necessary to land or take off. To minimize the chances of flying through an aircraft's wake turbulences, avoid flying through another aircraft's flight path. Rotate prior to the point at which the preceding aircraft rotated when taking off behind another aircraft. Avoid following another aircraft on a similar flight path at an altitude within 1,000 feet. Approach the runway above a preceding aircraft's path when landing behind another aircraft, and touch down after the point at which the other aircraft wheels contacted the runway. A hovering helicopter generates a downwash from its main rotor, similar to the vortices of an airplane. Pilots of small aircraft should avoid a hovering helicopter by at least 3 rotor disc diameters to avoid the effects of this downwash. In forward flight, this energy is transformed into a pair of strong, high-speed trailing vortices, similar to wingtip vortices of large fixed-wing aircraft. Helicopter vortices should be avoided because helicopter forward flight air speeds are often very slow and can generate exceptionally strong wake turbulence. Wind is an important factor in avoiding wake turbulence because wingtip vortices drift with the wind at the speed of the wind. For example, a wind speed of 10 knots causes the vortices to drift about 1,000 feet in a minute in the wind direction. When following another aircraft, a pilot should consider wing speed and direction when selecting an intended takeoff or landing point. If a pilot is unsure of the other aircraft's takeoff or landing point, approximately 3 minutes provides a margin of safety that allows wake turbulence dissipation. For more information on wake turbulence, see Advisory Circular 90-23. We'll hold off there. That is wingtip vortices on 4-8 and a little bit into 4-9. Alright, see ya.